Greetings. This is Nate's rendition of Homework Assignment 12, Problem 5. In Problem 5, we were given a system, as you can see graphically displayed, where ft plus nt is fed into a system with a particular output. We are charged to show that ht, an impulse in response, is equal to f star, the interval t0 to t, is the best receiver that maximizes the signal-to-noise ratio output, where the input ft is a deterministic signal and nt is a WSS, wide sense stationary, white noise, with a unit spectral density, where T0 is the output, this time instance. Excuse me. We will plot the filter response HT when the input FT is a rectangular pulse of duration T, and the output decisions are made at A, T0 equal to the duration divided in half, B, T0 equal to the actual duration, and C, when T0 is equal to twice the duration. We will continue this in the next section. Continuing with excuse me, homework 12, problem 5. The solution, as you can see, is graphically depicted with f of t plus nt being fed into our system, where the impulse response there is h of t equal to f star, the interval t0 minus t. Now it should be noted that y of t, the output, is equal to f of t0 asterisk, I would imagine some sort of conjugate, f star t0 minus t plus omega t. And in addition, the density, the spectral density, S of t is equal, it's also equal to the spectral density plus omega t. The signal noise ratio 0 is equal to the absolute value of the initial value of the spectral density, absolute value squared, over the expected value of omega t squared, which is equal to the absolute value of 1 over 2 pi, the integral from minus infinity to infinity, and testing whether it is less than the spectral density of omega times e to minus t minus t0, the absolute value squared, excuse me, divided by the autocorrelation of WW at its initial value. And as you can see, it's a rather complex, if you will, statement or equation, but in this segment of it, again, you have the absolute value squared, and within that absolute value, you have 1 over 2 pi, the integral from minus infinity to plus infinity of f of w, or omega, impulse response of WE to the JWT dW, divided by 1 over 2 pi, the integral from minus infinity to infinity of the absolute value of H of W squared, the spectral density Nn of omega d omega. And this breaks down even further, as you can see, and we end up with it equal to E sub F over sigma squared, okay, with the appropriate quality if and only if, excuse me, H of W is equal to F asterisk, the quantity of omega e to the minus JW T0. And we will finalize this in the next section. This is the last section of homework assignment 12, problem 5. And as you can see here, the filter is matched to the incoming waveform. And you can see with the baseline f of t versus the duration plus the negative f of t, as you can see, they're basically the same. They just go and expand out in different directions. For the initial value of t0, in this first example, it's divided by 2. In the second example, or graph rather, it is equal to the duration. And the third, it is twice the duration. Thank you very much. It's the end of presentation.